Okay, in the past couple of days, I've actually needed to use DWR's detailed analysis units, a data set of different hydrologic regions that DWR uses in the state. And I've needed to use this actually for multiple projects. So I thought this would be a good kind of real simple project to pull over and think about how we might use GitHub to distribute data for the Watershed Sciences Center. So if you look here, you can see that inside the Watershed Sciences Center, I've created this new project, California's Detailed Analysis Units, given it a nice little mnemonic here that you can figure out quickly, and have pulled in together a little overview of the kind of attributes that you can expect to see in this data and where it came from. This data set's kind of interesting in the fact that although it's still available for download, it's quite hard to find on Google, at least it was for me. So I thought that maybe in this case, not only would we want to store the process data that we're creating or that I'm creating and that I need, but I actually might want to store the source data as well. So when I created this project, you can see that I've actually have versions for the source, which has the original source, and I have a shapefile version as well, and I have a GeoJSON version as well. So there's two kind of versions of the final product that I needed, and then the original source as well. And I'll actually make a quick little video that shows some of the tricks that I used in order to create the project or the final product. But on this, I'm going to concentrate a little bit on what we can think about doing for standardizing data sets. And this is one of them, actually. In this case, we might actually standardize on the type of names that we use and the types of formats that we use. For California, for example, it's nice that we use California Albers NAD83 for most of the projections. So that's one of the things that I did to standardize this particular data set. Once you do it this way, it's very nice. It's convenient for somebody that's going to want to make modifications. They can pull down this entire data set and they can see all of the steps that you went through to create it. In my case, I have a tendency to use makefiles in order to do that. This makefile includes areas that show I went and downloaded the data, what I used to create the data, a GeoJSON version and the shapefile version. And it actually also includes some additional features. So if I want to import this into PostGIS, for example, I can pull this down, run a command, get it into a PostGIS data set, and then go from there. Another thing that we can actually do with data products here is that this is very nice if you're going to actually modify the data. You clone this data set, you could actually look at it, make changes to the way the data was created. But if you're just trying to use the data, that's probably not going to be what you want to have. And here you can see that if I just do a poll from that particular data set, I'm actually going to get directories for the GeoJSON and the shapefile and the source, the original source file. When really, what I probably only want to have is the source, the shapefiles, and maybe the GeoJSON file, if I'm only going to use this data as opposed to work on it. But there's some tricks that we can use to actually improve that behavior as well. What we can do is instead of expecting that users of the data will be cloning this source, we can actually expect them to be pulling resources from it. So one thing that DWR or that GitHub has as well is in the releases section, you can download tar files or zip files of particular releases. And what we can do in this case is actually, if you go into your project that you're working on, you can actually use a get attributes function. And what this allows us to do is actually identify parts of the project that we want to ignore. So in this case, I'm going to ignore all of the source data, and I'm going to ignore some of the data files that I was used to create it. So what's nice with this is if we go in and we use this get attributes function in our project, and then we create a new release, then when that release comes and we download a particular zip file from one of these, then we'll actually only get the data that's included in that particular release. So once this finishes loading, you can look at that zip file and see that only the data itself is located. And what's actually nice in that as well, you might not be able to see this in the video, is that the data is actually identified both by the identifier but also by the version that you're using. So this is really nice because people that are using this for data products can see not only the data product but also the version, and if versions have been updated, then they know that they're out of date with that. All right. Finally, I just wanted to make to mention that when I actually download the GeoJSON file of this data, I don't use the Thiel-Elber's projection. I use standard WGS 84. And one of the reasons to do that is that you can use that GeoJSON file within GitHub to give users kind of a default nice little view where they can see the kind of data that they're looking into downloading. And they can also look at the individual attributes inside them. So that's kind of a really nice feature to build into our projects as well. All right.